Imagine a liquid so bizarre it can flow forever without stopping, climb up and over the walls of its container, and squeeze through gaps too small for even air to pass through. This isn't science fiction. It's a superfluid, and it might be the strangest state of matter in our universe. When you cool helium-4 to an extreme temperature of negative 270.98 degrees Celsius, just 2.17 degrees above absolute zero, something magical happens. The helium transforms into what physicists call a superfluid, a state of matter first discovered in 1937 by Soviet physicist Pyotr Kapitsa. What makes superfluids so extraordinary? For starters, they have precisely zero viscosity, meaning they flow with absolutely no friction. Pour a normal liquid into a circular loop, give it a push, and it will eventually stop. But set a superfluid in motion, and it will theoretically flow forever. Perhaps most mind-bending is superfluid helium's bizarre ability to defy gravity. When placed in a container, it will spontaneously creep up the walls and escape by flowing over the edges. Even more astonishing, superfluids can leak through microscopic holes that even normal gases can't penetrate. Scientists have observed superfluid helium passing through pores just a few atoms wide, something that should be physically impossible for normal matter. The science behind these properties comes from quantum mechanics. At ultra-low temperatures, helium atoms enter what's called a Bose-Einstein condensate. They begin to behave not as individual atoms, but as a single quantum entity. In 2003, NASA created the coldest known spot in the universe aboard the International Space Station, reaching just billionths of a degree above absolute zero. In this extreme environment, they've been able to study how superfluids behave without the complicating effects of Earth's gravity. Superfluids remain one of physics' most exotic oddities, a state of matter that seems to break the rules we take for granted. They remind us that at the extremes of our universe, reality can be stranger than imagination. And they raise an intriguing question. What other bizarre states of matter might be waiting for us to discover in the coldest corners of our cosmos?